This is the circuit we'll be making today. So this is a circuit diagram for the circuit I just showed. So we have the 7-volt power supply here. And then we have the 680 ohms resistors going into the LEDs, which go into these transistors. So what happens at first is, since no two capacitors or no two components are exactly the same, one of these capacitors will charge quicker through their resistors. So let's say this capacitor here charges up first. Let's call this side of the circuit, we will number them with 1, and this side with number 2. So when capacitor 1, C1, is charging, then the Q2 on this side, it gets a base current and thus it is open. So Q2 is on. Then C2, because Q2 is open, C2 is now discharging to ground. So we'll write that down. Then Q1 is closed, is off, sorry. And finally, LED 2 is on, since the path is open to ground for the LED. So the result is that LED 2 is on. When C2 is charging, then it opens, the current flows from here, goes through here, charges up this plate, and then the current flows here and into this transistor's base, which is Q1. So Q1 is on. Then Q2 is off. And C1 is discharging. And since this transistor is it's closing the path, this LED 1 turns on. So that is how this circuit works. So let's see how we can build this circuit here. So we'll get the breadboard, and then we'll start on this side here. So we'll get the 680 ohm resistor, and we will connect it like so. Then we'll get an LED, and we'll connect the positive end to the resistor, like this. Then the negative end of on the negative end of the LED, we'll connect the capacitor, and we'll leave a bit of a gap. So, like this. And then we'll connect the transistor to the circuit. So, the first transistor will connect the collector here to the negative end of the LED. So on the right side here is the collector, and we'll connect it like this to the negative end of the LED. Now what we'll do, we'll connect the emitter of the transistor to ground, this connection here. So I'll get a wire like this, and I'll put it to the ground like so. There you go. Now we can connect the 47 kilo ohm resistor to the other end of the capacitor, like so. So if I now get a 47 kilo ohm resistor, I will connect it from the plus end of the battery to the other end of the capacitor. So now we can begin on the other side. So if I get another 680 ohm resistor, I will put it here, just like this. Then I'll get another LED, and I'll get the positive end, and I'll connect it to the resistor. Then the negative end of the LED here will go to the capacitor on this side. And again, remember, we're making this space so that we can fit the transistor here, like So yeah, so we make a bit of a space like the last one, and then we fit the capacitor. Again, the collector is connected to the negative end of the LED, so we'll connect it like that. Then the emitter goes to ground, so get a wire and I'll connect it to ground, just like that. Now we can connect the 47K to the other end of the capacitor, like this. And then we can connect the bases to the opposite capacitor. So let's connect, say, this one to that capacitor. So I'll get a wire like this, connect that to the base, and then to the other end of the capacitor. And this connection is this one here, from this end to that end over here. Then we'll connect the other one from here to there. So we can connect it, we'll get the other end of the capacitor like so. We'll connect it right at the base, like that. And that all fits snugly, like so. Now if we test it out, now here's this full circuit. So if we test it out by plugging power in, we should see flickering. So there you go. And we have our flashing lights circuit. So what if I replace this 47 kilo ohm these 47 kilo ohm resistors with different resistor values? So for example, what if I change this 47 kilo ohm resistor here to a 10 kilo ohm resistor? Then what happens is, since it's a smaller resistor, there's more current to discharge this capacitor here, which means that this LED stays on for a shorter time. So let's test it out right now. Let's see what happens. So if I take this 47K out and replace it with a 10 kilo, like so, what happens when I plug the power in is this LED will stay on for a shorter time. Oh, sorry, the other one. That will stay on for a shorter time. So if I take that out now, so if I replace it with a bigger resistor, say 1 mega ohm, what would happen? What happens this time is, since it's a bigger resistor, if this is 1 mega, then since it's a bigger resistor, there's less current to discharge this capacitor here, which means that this LED stays on for a longer time. So if I replace that resistor with a 1 mega ohm resistor, we should see that this LED stays on for significantly longer, like so. And did you see that blinked quicker since it stayed on for a shorter duration? And then this stays on for much, much longer. So that is what happens when you change these resistor values. So if I have the same resistor value, for example, if I have both of them as 1 mega ohm, that means I would replace this other resistor here with a 1 mega ohm. And what will happen is, now they're both the same duration, but they're both very long. Like this. Stay on. That stays on. It's like this. So you can see that they're the same duration, but they're much longer than when we had previously. Hey there, thanks for watching this video. If you like this video, you might also like this random video up here. You might also want to watch this video down there. I bet you'll enjoy it. Thanks for watching, and see you in another video.